Today we solve this question from Wassce June 2014, question number 9. And we'll be solving the number 9b. It says that when the polynomial f of x equals s cubed plus as squared plus bx plus 3, where a and b are constants, is divided by x plus 2 all raised to the power 2, the remainder is 0. Find the values of a and b, and we have to find the zeros of f of x. So that's how we're going to proceed here. Alright, so the first thing I will do is that I'll write down the function, and it's f of x equals s cubed plus as squared plus bx plus 3. So we have to find the constants that we have here, that is a and b. So we have a here and we have b there, and we have to find a constant here. What we're going to do here is that we are told that the function is a cubic function. Of course, we see that the function is a cubic function here, f of x. The highest degree of f of x is 3, so that means that it is a cubic function. So one thing that we have to note here is that a cubic function has 3 roots. So let me write that down. The cubic function has 3 roots, and of course it also has 3 linear factors. So a cubic function 2 has 3 linear factors. So it has 3 roots and it has 3 linear factors. So we are going to use the idea that the cubic function has 3 linear factors to find the values of the constants a and b. So first, we are told that when the function f of x is divided by x plus 2 raised to the power 2, there is no remainder. So that means that x plus 2 raised to the power 2 is a factor of the function. So let me also try and capture that one here too. So we are told that if f of x is divided by a quadratic, that is x plus 2 raised to the power 2, the remainder is 0. The remainder is 0. So this tells us that x plus 2 raised to the power 2 is a factor of the cubic function f of x. So this implies that x plus 2 to the power 2 is a factor of the function f of x. Now x plus 2 to the power 2 is a quadratic, and it has 2 linear factors, and it has 2 linear repeated factors. So what we can write or say is that x plus 2 so x plus 2 raised to the power 2 is equal to x plus 2 times x plus 2. So you have to understand that if x plus 2 raised to the power 2 is a factor of the function f of x, or in other words, if x plus 2 raised to the power 2 divides the function f of x to give 0, then it means that any of its linear factors will also divide f of x to give 0. That is also a factor of that. So what I'm trying to say here is that we have the function f of x, and first we are told that there is another function that is x plus 2 raised to the power 2 that divides to give a remainder of 0. So we are told that x plus 2 to the power 2 is a factor. So it's a factor means that when it divides f of x, we get a remainder to be 0. But s plus 2 raised to the power 2 is s plus 2 times s plus 2, and these are 2 linear factors. And for a cubic function, it has 3 linear factors. So that means that we have one more linear factor that we have to put here. So what I'm going to do is that I'm going to expand x plus 2 raised to the power 2 so that we can have a quadratic here. Now when I expand this, I have x raised to the power 2 here, then I'll put a 2 here and square the 2, and what I'll have in here will be 2 times x, and that will be 4x. So in effect, I'm going to get x squared plus 4x plus 4 as the quadratic factor of the f of x. So now the function f of x is a cubic function, and one of its factors is a quadratic. So that means that it's left with only one linear factor. So f of x will be equal to it has three factors, but we have x squared plus 4x plus 4 to be a quadratic factor. So this quadratic comprises two linear factors, and these are x plus 2 and x plus 2. So that means that it is left with a third linear factor, which we do not know. So I'm going to say that let it be something else. All right, so we have something like because we have a and b here, I don't want to use a and b, I want to use c and d so that we can have distinct constants here. All right, so I'm going to write cx plus d, where cx plus d, the basic format of a linear function is what you see here. If you remember, a linear function can be written as y equals mx plus c, where m and c are constants, or let me say ax plus b, where a and b are constants. So that is essentially what I'm doing here. I am just writing down a linear function, a basic or general linear function, where c and d are factors. All right, so I am saying that let cx plus d be a factor of the f of x. All right, so let me add something small here, where cx plus d is a factor of f of x. So that is essentially what I'm talking about. Okay, so what I'm going to do is that I'm going to clean the whole of the board and start everything afresh, and this time around I will present a step-by-step solution to that. So first, what I wanted you to understand is that f of x is a cubic function, and because it is a cubic function, it has three linear factors, and because we are told that x plus 2 raised to the power 2 divides the function f of x to give a remainder of 0, then x plus 2 raised to the power 2, which happens to be a quadratic, is a factor of f of x. And if indeed it is a factor of it, then we are left with one linear factor to find a full function. All right, so here we are told that f of x equals s cubed plus as squared plus bx plus 3. Okay, and we are also told that x plus 2 raised to the power 2 divides f of x to give a remainder of 0. So that means that x plus 2 raised to the power 2 is a factor, right? So I'm going to write something down here that x plus 2 raised to the power 2 is a factor of f of x. And because x plus 2 to the power 2 comprises two factors, we are now left with a third factor. Mind you, I said that a cubic function has three factors. So what I'm going to write here now is that I'm going to say that let a certain cx plus d be the third factor, or let me say a factor of f of x. So let it be a factor of f of x. So now we have all the factors. We have x plus 2 raised to the power 2, then we also have cx plus d. So that means that we can write, so this implies that we can write the function f of x to be equal to the product of its factors. All right, so we can have x plus 2 to the power 2 times cx plus d. So that means that when we expand the factors of the function, we should get the function. All right, so here we are going to expand the quadratic that we have here, that is x plus 2 raised to the power 2, and when we do that, we will have s squared plus 4x plus 4. So the whole of this is that times cx plus d. Okay, so the function f of x equals this. Now we will go on to expand this one too. So we will have f of x to be equal to, so here we will have x squared times cx, and that is going to be cs cubed. Okay, then the second thing, we will have x squared times d, and that is going to be dx squared. So now we move from the x squared, then we go on to the 4x. All right, so we have 4x here, so now we have 4x times the cx, and 4 and c are constant, so we will have something like 4c, then we have x times x, and that will be x squared. Okay, plus, then we have 4x times the d. So 4 and d are constant, so we have 4x times d. So we are going to have 4d, then we have the x. Okay, so we're done with the 4x. We now move on to the last term, that is the 4. So we look at the 4 also here. All right, so we have 4 times cx, and that is going to be 4cx. Then we have 4 times d, and that will be 4d. So that is the expansion. But let us arrange this wall. Let us write this wall, because the function is a polynomial in the variable x, right? So we have to the power 3, to the power 2, to the power 1, and 0, and so forth. All right, so the first one is going to be cx cubed. The second one is to the power 2. So we have here to the power 2 here. We have to the power 2 here. So what we can do is that we will simplify by factorizing out x squared. So here we have d plus 4c or x squared here, and here too we have the xx here. So we are going to have the 4d here, okay, plus the 4c also there, then or x, and the last one, which has no term in x, that is x to the power 0. Here we have 4d here. All right, so that is what we will have for the function, and this should be equal to the function that we were given. All right, so what I'm doing here is, this is the function the question gave to us, and we have been able to derive this function using the factors of f of x. So we can equate the terms term by term. All right, so let me write something here. But we are saying that f of x equals x cubed plus ax squared plus bx plus 3. So that means that I can write the whole of this term, or the whole of these terms here. So I'm going to have something like x cubed plus ax squared, right, plus bx plus 3 equals all the term on the right hand side here. So let me write that in a different ink. So I'm going to have cx cubed plus d plus 4c x squared, then we have 4d plus 4c x plus 4d. So now we can equate or compare the terms on the left and the right. That is what we want to do here, so that we find the values of a and b, because we've been asked that we have to find the values of the constant a and b. So the first thing we do is that we compare the coefficient of x cubed. Here we have x cubed here, and the coefficient of x cubed is 1 here. All right, and here we have x cubed, and the coefficient of x cubed is c. So let me write something small here. So we are going to compare. So I'm writing by comparing terms on the left hand side and right hand side. That is what we can deduce from that. Here the coefficient of x cubed is 1, and here that of it is c. So this implies that c is equal to 1. But we were not asked to find c, we were asked to find a and b, but in the course of that we've had c and we have also had d, so that is cool. Let's go on to the next one. Here too we're saying that on the left hand side the coefficient of x squared is a, and on the right hand side too we have d plus 4c. So this implies that we can say that a equals d plus 4c. But we know c, right? We know c, so we know c to be 1 here. So if we can know d, then of course we can know the value of a. So let us go on here. Okay, let me try to look at the x2. So with the x here, the coefficient is b here, and on the right hand side we have 4d plus c. So this implies that we can also write b, that is on the left hand side the coefficient of x is b, and on the right hand side the coefficient of x is 4d plus 4c. So on the right hand side we have something like 4d plus 4c, and of course we also know the c here to be 1, but it is the d that we don't know, and of course we can know d from here. When we look at the last term, the left is 3, it has no x. The right 2 is 4d, it has no x. So these constants are equal. All right, so we can also say that 3, let me write that in another ink. I think the value to do. All right, so we can say 3 equals 4d, And from here we can find d by dividing both sides by 4, so that this implies d equals 3, 4. So now we know d, and we know the c2. All right, we know c to be 1, then we know d to be 3 out of 4. So this implies that we can now find out a. So this implies that a equals d, and d is 3 out of 4 plus 4 times c, and c is 1 here. All right, so we're gonna have something like that, and this will be equal to 3 out of 4 plus 4 times 1 is 4. So let us find the LCM here. It's 4 here, 1 times 3, 3, 1 here, 4 times 4, 16, and 3 plus 16 is 19 out of 4. So a is 19 out of 4. Let us check the b2. All right, from here to we have b to be equal to 4d plus 4c. All right, so what is the d? All right, d is 3 out of 4. So we have 4 times 3 out of 4 plus 4, and the c is 1. Okay, so we have 1 here. So b is going to be, all right, 4 here, 1, 4 there, 1. So we're going to have 3, and 4 times 1 is 4. So b is equal to 7. All right, so we've been able to find the values of a, that is 19 out of 4, and that of b is 7. All right, so therefore I values of a is equal to 19 out of 4, and b equals 7. All right, so we look at the II, and it says find the zeros of f of x. The zeros of a function are the set of values that when you put into the function you get 0. In other words, they are the roots of the function. They satisfy the equation of the function. Now, what is the function? From the question, f of x, that is the cubic function, equals s cubed plus as squared plus bx plus 3. All right, but we've been able to find the values of a and b, so let us simplify this and look at the function well. So we have s cubed plus, and the a we had 19 out of 4, and the b2 we had 7. So that is the function. And if you look at the way that I solve it, I told you that f of x is expressed as s squared plus 4x plus 4, then cx plus d. All right, this is what I talk about. And of course, the quadratic has 2 repeated linear factors, so it was something like this. And when we solved this, we were able to find the values of c and d. So from here we had x plus 2 squared, and c was 1, so we had x plus d, and of course d2 was, I think, 3 out of 4. All right, so if we are to find the zeros of the function, I can just say for zeros I'm going to equate the linear factors to 0 for zeros of the function of f of x. That is what I can do. I will pick the first linear roots, that is x plus 2, and equate it to 0. So x will be -2. So that is one of the zeros of the function, and it's a repeated root. So I have x equals -2, and the next one will be the same thing, because that is x plus 2 raised to the power 2. So I will still have x plus 2 equals 0, and x will be equal to -2. So this will be the second zero of the function, and the third zero will be this equated to 0. So that will be x plus 3 out of 4 equals 0, and that is going to be x equals -3 out of 4. That is pretty simple. So because I equated the function to these linear factors, finding the zeros was pretty much easy. Okay, because I just found the factors. I knew 2 repeated factors, and I just had to find the third linear factor. And there is another way to do this. You can also divide the function by any of the factors that you know. In this case, we know the factor x plus 2 raised to the power 2, or s squared plus 4x plus 4. So what I'm saying is that we could have also solved it like this. We could have divided the function f of x, that is, we will have x plus 2 to the power 2, or let me write it in its quadratic form. That would be great. So we could have also had x squared plus 4x plus 4. Okay, dividing the quadratic, the cubic function, x cubed plus 19 out of 4 x squared plus 7x plus 3. All right, so that is going to divide the whole of this, and what will be left will be the other linear factor, and from that I can find the zeros of the function. I think that is not even necessary because already you were able to find the linear factor, that was x plus 3 out of 4. All right, but in the event you did not solve it that way, because there is another way that we can solve this, and I will show you that way too. So when you divide this by that, x squared goes into x cubed, you have x. Okay, and let me use another ink here. All right, so x squared goes into x cubed, you have x, and x times s and x times x squared, you have x cubed. Okay, all right, plus we have x times 4x, you have 4 x squared, then you have x times 4, you have 4x. So what you do is that you subtract here. All right, so here will give me 0, and 19 out of 4 x squared minus 4 x squared, what is this going to give me? Let me do some slight calculation here. So okay, let me ignore the x squared for now. So minus 4, let me find the LCM here. 4 here, 1, 19, 1 here, 4, 16. So that's going to be 3 out of 4. Okay, so I'm going to have 3 out of 4 x squared, and when I subtract 4x from 7x, I get 3x. Okay, and here is 0 because there is nothing here, so 3 minus 0 is going to give me the 3 here. Okay, so the next thing that I do is to divide the next term here, that is the 3 out of 4 x squared by x squared, and I'll get 3 out of 4. Okay, so 3 out of 4 times x squared, I have 3 out of 4 x squared, and 3 out of 4 times 4x, let's look at it very well here. 3 out of 4 times 4x, 4 will cancel 4, so you have 3x here. Okay, then we have 3 out of 4 times 4, then we have 3 out of 4 times 4, and that is also 3, so you have 3. So when you look at the terms here and there, they are the same, because term by term you can even see that they are the same. So you have 3 out of 4 x squared, 3 out of 4 x squared. When you subtract, you get 0. Here too you have 0, here too you have 0. So because the remainder is 0, it implies that x plus 3 over 4 is a factor of this. So we can write the cubic function f of x as x squared plus 4x plus 4, then x plus 3 out of 4, just like the first one that we saw. So that is why I told you that it is not even important dividing this if you use the approach that I used to, right? But there is another way that we can also solve this, and we will be looking at that one too. But in the event you do that, you have to look at how you can divide this polynomial, and perhaps we will come back to it when we get there. All right, so that is one way you can solve this question, but we can also look at another way. All right, so another way that you can solve this question is the application of calculus. All right, so we can apply almighty calculus, specifically differentiation. We can use differentiation to solve this question. If you look at the first one that we solved, we kind of applied some techniques in polynomials, so let me say algebra basically, but we can also apply differentiation to solve this question, and that will be our next task here. All right, so I'm going to write down the function again, that is f of x equals x cubed plus ax squared plus bx plus 3. Now before you proceed from here, normally when I talk about curves, I tell my students that you must at least know the type of curve that you're talking about. The curve that we have here is a cubic curve, but what is the shape of a cubic curve? A cubic curve is either like this or like that. Okay, if you look at these two, they are different. If you look at the first one here, the shape here is like n, and the one here is like a u, so it's like a fusion of n and u, yeah, making something like that. So u and n, if you look at this shape, and if you look at this shape too, it's like we have the first one, that is the one on the left hand side, it's rather the u, and the shape on the right hand side is the n. So if you look at this one, that's how it is. So whereas the top one we have NU, something like nu, NU, you see, and you, nu. The second one we have something like earn. In French, when they say earn, it means one. All right, earn day. Right. So if you look at the one we have top there, it's like nu. The one down here is earn. So the question is, which one of these is this curve? Now you can tell the shape of this curve by looking at the sign of the coefficient of s cube. Now if you look at the s cube here, it has a coefficient of +1. Now when the coefficient of s cube is positive, let me try to explain this. It's pretty much important here. Now if you have something like this, if the s cube, the number that stands with the s cube is say positive, in this case say 1 here, the shape of the curve will be something like this. You see, if it is 1, what I'm trying to say is that the u will be on the right hand side. I normally tell students that the cubic curve is like a fusion of two quadratic curves. Now when you take a quadratic curve which has a degree of 2, it's something like that. And when it's like a cap or u, it means the a, that is the coefficient of the s squared, is positive. So when it is positive, it's kind of look up, the curve looks up. But if the coefficient of a for a quadratic, this one is for a quadratic I'm talking about, please, so don't get confused. We are dealing with a cubic curve, but I just want us to look at a quadratic curve, because if you look at a cubic curve, it's like we have fused two quadratic curves. Okay, and when the a is negative here, let me use another color here, I forgot. All right, so when the a here is negative, then the shape of the quadratic curve is down. So I normally say that because of the negative sign, nobody likes anything in his life that is negative. Because of that, the curve even does not like it, so the curve turns upside down. All right, and when it is positive, the curve turns upside, or it turns up. All right, so that is absolutely what we mean by a quadratic curve, these two shapes. Now when the a, or the let me say the coefficient of the s cube, that is in terms of a cubic function, the one that we see here, when it is positive, let me clean this too. When for a cubic curve, all right, cubic curve, when the coefficient of the s cube, that is the a, is positive, then I said that when it is positive, you have the u shape. All right, so when it is positive, the u shape begins on the right hand side. Something that is positive, of course, goes to the right hand side, so you can also think of it that way. So when the a is positive, we have the u on the right hand side. Then so from there you continue to the left hand side, and the shape will change to the n shape. So it's something like that. Okay, and when the a is negative, then because it is negative, this time around we are going to have something negative happening on the right hand side. The right hand side is pretty much important. So when it is positive, something positive happens on the right. When it is negative, something negative happens on the right. So because it is negative, the shape will be something like this here. Then it will continue to the right by turning up. Okay, so if you look at our curve here, because the coefficient of the s cube is 1, that is +1, this will be the shape of our curve. So I don't even know a or b, but because of the coefficient of the s cube, I know the shape of my curve. And because I'm dealing with calculus, I might be tempted to draw the curve to have a better look at it. All right, so that is why I must know how the curve will look like. Alright, so from here, that is what I'm going to do here. I'm going to look at the information that I was given. Again, we were told that x plus 2 raised to the power 2 divides f of x. It divides f of x without a remainder. Okay, in other words, or let me say with a remainder of 0. That is the same as without a remainder, because the remainder was 0. Or let me put it that way so that I will state exactly what the question is saying. So let me say it divides it divides f of x with a remainder of 0. Okay, I think this looks better. Okay, so when a quadratic divides a cubic function and the remainder is 0, it means x plus 2 raised to the power 2 is a factor. So this implies that x plus 2 raised to the power 2 is a factor. Is a factor of f of x, and I think that is pretty much clear. All right. For example, we know that 3 is a factor of 6. Why? Because 3 divides 6 exactly without a remainder, or when 3 divides 6, the remainder is 0. And we know that 5 is a factor of 10. Why? Because when 5 divides 10, the remainder is 0. So when we are told that x plus 2 raised to the power 2 is a factor, when we are told that x plus 2 raised to the power 2 divides a certain function f of x with a remainder of 0, what tells you? Of course, it tells you that x plus 2 raised to the power 2 is a factor of f of x, just as 3 is a factor of 6 because 3 divides 6 without a remainder or with a remainder of 0. Okay. All right. So if x plus 2 is a factor or divides f of x to give a remainder of 0, then that is what we can say. You know, x plus 2 to the power 2 can be expanded as x plus 2 times x plus 2, because of course x plus 2 raised to the power 2 is a repeated linear root. Now if x plus 2 raised to the power 2 is a factor of f of x, then any of the linear factors is also a factor of f of x. I hope it is clear here. Okay, that is what I'm trying to say here. Let me try to give an example here. 10. If we are told that 10 is a factor of 20, this is true, okay, because 10 divides 20 without a remainder, or let me say with a remainder of 0. I want us to compare this to what is happening here, and let me write this. X plus 2 raised to the power 2, we are told that is a factor of f of x. Okay, now I want us to compare the numbers to the function that we have here so that we can have a better understanding. Now when you are told that 10 is a factor of 20, that means that 10 can divide 20 without a remainder. But does 10 also have factors? Of course, 10 has factors, and some of these factors are 2 and 5. Okay, listen carefully. 10 is a number, okay? It divides 20 exactly, so 10 is a factor of 20. But when we go into 10, which is the divisor, which can divide 20 exactly, 10 too has factors, which are 2 and 5. So the question is, can 2 and 5 also divide 20 without a remainder or with a remainder of 0? In other words, is 2 also a factor of 20? Yes. Is 5 also a factor of 20? Yes. Does 2 divide 20 to give a remainder of 0? Yes. Does 5 divide 20 to give a remainder of 0? Yes. So because 10 is a factor of 20, factors of 10 will also be factors of 20. Okay, now look here. We are saying that x plus 2 raised to the power 2 is a factor of f of x. But what are the factors of x plus 2 raised to the power 2? The factors of x plus 2 raised to the power 2 is x plus 2 and x plus 2. So does that mean that x plus 2 can also divide f of x with a remainder of 0? Yes. So if 10 is a factor of 20, then factors of 10 are also factors of 20. Then if x plus 2 raised to the power 2 is a factor of f of x, then factors of x plus 2 raised to the power 2 are also factors of f of x, and that makes sense. So that is what we are trying to do here. We are trying to break down the quadratic to get its linear factors. Of course, that is what we want to work with, okay? So we can also say confidently that x plus 2 is a factor of f of x. And if that is the case, then we can write that we can equate x plus 2 to 0 and find the value of x, and that is negative 2. Now if you are told that x plus 2 is a factor of f of x, then this implies that when we put the value of the x here, from this linear factor x plus 2, that is negative 2, into the function, we get 0. So that is what it means. If you are told that x plus 2, let us try to understand this one. We call it the factor theorem. We call it the factor theorem. So we are saying that examples, let me give some examples. Example, if say x plus 3 is a factor of a certain function, let's call the function f of x, then what can we say? Then we can say, then this means that f of negative 3 is 0. So how did we get a f of negative 3? Now you take the factor, that is x plus 3, and you equate it to 0. You find the value of the x, so that will be negative 3, because if you send the 3 to the right hand side, you have negative 3. So that means if you put that value of x into the function, you get 0. Let's take another example. Another example is that if you are told that, say, the linear factor, if say x minus 5 is a factor of, let's take another function, say the function g of x, okay, then what can we say? What we can say is that then g of 5 is equal to 0. Now why are we saying g of 5? Where did we get a 5? Now we take the linear factor x minus 5, equate it to 0, and make x the subject. So that is going to be x equals, the sign here is negative, right? So when you send it to the right side, we have positive 5. So that is exactly what we're talking about here. Because we are saying x plus 2 is a factor, then we can put in negative 2 into the function and we should get 0. Alright, so now let us try to solve this. This should be simple. Now this is the function we have been given. We are told that f of x equals s cubed plus as squared plus bx plus 3. Okay, and now we are saying that f of negative 2 equals 0. So that means where we see x, we put negative 2. So f of negative 2 equals, so now x is negative 2. So we have x here, negative 2. Sorry, it is a rather, it's not 9. It's a, so we have a here, we put negative 2 in squared, b negative 2 plus 3. Alright, but we are told that if s plus 2 is a factor, then f of negative 2 equals 0. So f of negative 2 is equal to 0. So where we have f of negative 2, we write 0. So negative 2 to the power 3 is negative 8. Negative 2 to the power 3 means negative 2 multiplying itself 3 times. Sorry, 3 times. So we have negative out here, and still we have a negative sign here. So 2 times 2, 4 times 2, 8. But it is negative, so that's going to be negative 8. The next term is negative 2 to the power 2, and that is positive 4. So we have 4a. And we have b times negative 2, and that is negative 2b. Then we have plus 3. Alright. So we should group like terms here, okay? 0 here. We have negative 8 here. Then let me bring the positive 3. Let me write 4a minus 2b here. Okay. So let me simplify this here. That is going to be negative 5 plus 4a minus 2b. Okay. So from here, what am I doing? Let me send the negative 5 to the left side. I'll have positive 5 here. Then I'll have 4a minus 2b. Okay, let me write this term on the left, 4a minus 2b, and let me put the 5 on the right. Let me call this equation 1. Okay, so from just one statement here, that when x plus 2 raised to the power 2 divide the function f of x, we get a remainder of 0. I've been able to deduce an equation that is 4a minus 2b equals 5. Now I am asked to find the value of a and b. So there is my a here and there is my b. But because I have two, let me say two variables, or let me say two constants to find, that is the a and b, I need at least two equations. Of course, I cannot find a and b using this one equation. So how do I get the next equation? That'll be my next job. Alright, so let me document what I'm doing now. We began with a function. There was a certain function that we wrote down initially, and we were told that x plus 2 is a factor, but we also knew that s plus 2 raised to the power 2 equals s plus 2 times s plus 2. And if s plus 2 to the power 2 is a factor of f of x, or is a factor, let me add here, of f of x, then that means the linear factors s plus 2 are also factors. So this implies that x plus 2 is also a factor of f of x. So if it is also a factor of f of x, then I can equate s plus 2 to 0, and I'll find the value of x to be negative 2. And if I put this into the function, I should get 0 because of the factor theorem. And I went on to put in this, and I had negative 2 to the power 3, a negative 2 squared plus b negative 2 plus 3. I went on to simplify this, and I had 0 here, negative 8 here, I had 4a here, I had negative 2b plus 3, 0, negative 5 here, plus 4a minus 2b, and I rewrote this well, and I had something like 4a minus 2b equals 5, and I call this equation 1. So these are the steps that we have derived so far. And I was saying that I cannot solve this, I cannot find the values of a and b without having two equations, and we have just one here. And there is one more thing happening here. Now we are told that x plus 2 raised to the power 2 is a factor of f of x. Now, because we are told that x plus 2 raised to the power 2 is a factor of f of x, then it means f of x has repeated factors. So, but we know that f of x has repeated factors, or let me say repeated roots, that is at negative 2. Now there is something that we have to pay attention here. Any cubic function has 3 roots, alright? 3 distinct roots, 3 different roots. And when we talk about the roots, they are the solutions, they are the zeros of the function. Let me try to draw a cubic function so that we look at what I'm trying to say. Now let us take this to be the xy axis. That is the x-axis, that is the y-axis. Now in our case, we know the shape of our curve, right? It's going to be something like that. Okay, so what I'm trying to say here is that the roots of this curve will be at a point where the curve intersects the x-axis. So one is here, the second one is there, and the third one is here. Now this happens when the curve has 3 distinct roots. Distinct, it means 3 different roots. But in our case, that is not what is happening. All right, in our case, we don't have only distinct roots, we have repeated roots. Some roots are repeating, because we are told that x plus 2 raised to the power 2 is a factor, and that is equal to s plus 2 times x plus 2. So it means that at the point where x equals negative 2, the roots of the curve is repeating over there. And there is something that we have to take note here. Now anytime that we have a cubic function which has 2 repeated roots, it means at that repeated root, one of the turning points is occurring there. That is the trick. That is the trick we have to use to solve this. Okay, now I'm trying to say this again. Now if you look at this curve that we have here, any cubic curve has got 2 turning points. This part is called a turning point here, and here too is called a turning point. Now this one turning upward there, we call it the maximum turning point, and this one turning down here is called the minimum turning point. All right, so do you know the point at which the curve turns? From here it is turning somewhere here, but do you know the value of x? Of course not. It cannot tell for sure. But when the curve has when the curve has repeated roots, then we can tell where the curve, one of the curve turning point is happening. All right, so that is what we are going to use to continue to solve this. Now let me try to sketch the curve a little bit so that you have a good dose of what we're talking about here. Now to sketch a curve, you need 3 basic things: the x-intercept, the y, you need 3 basic things: the x-intercept, the y-intercepts, and the turning point. So to sketch a curve, first we talk about what we call the intercepts on x and y. But I'll first look at the y. So I'm going to look at the y-axis. Now on the y-axis, for y-intercepts, that is where the curve intersects the y-axis, the value of x is 0. So I'm going to draw the xy axis again. This time around, I'm very careful to draw our curve, so pay attention here. Now this line that you see here, I know you know this is called the x-axis, but I don't know if you also know that this same x-axis is called the line y equals 0. Okay, and this line here, I know you know that it's called the y-axis, but do you also know that this line is also called the line x equals 0? Yes, it makes a lot of sense here. Let's try to understand why we call it that. Now, if you ask to plot, say, the points 3, 0, what does it mean? The point 3, 0 means that the coordinate of x is 3 and the coordinate of y is 0. So it means the y here is 0. Now, if the y here is 0, where does the point lie? Let me try to calibrate this. Let here be 0, 1, 2, 3, 4, -1, -2, -3, -4. Then here 2, +1, +2, +3, -1, -2, -3. So now where will this point lie? We have 3, 0, so that means 3 on the x-axis, and so the point will lie here. You see, so 3, 0 lies here. Then what about the point 1, 0? It will also lie here. And what about the point 4, 0? It will also lie here. So if you look at it, all the points are lying on this line that we call the x-axis, and it is happening because the coordinate of the y is 0. So we are trying to say that when the y is 0, it will lie on this x-axis, and that is why it is also called the line y equals 0. And also the same thing applies here. If I ask you to plot the point, say 0, 1, it means the x is 0, the y is 1, so you come over here and plot it here. Okay, so this line is also called the line x equals 0. Now let us draw our curve. Our curve is f of x equals s cubed plus as squared plus bx plus 3. So for the y-intercept, the value of x is 0. So where I have x, I write 0. Okay, so f of x is 0 here. I have s cubed, so 0 cubed, as squared, so a 0 squared, bx, so b times 0, then plus 3. Now you can see that all of these are multiplying 0, so that will go to 0. So f of 0 will be 3. So the points will be 0, 3. So that means that our curve will be passing the point 0, 3 here. And I have said that, because the function, the cubic function f of s, has repeated roots at where x equals -3, the curve will turn here. It will turn here. So it means the curve will turn here, and it will also turn at one other point. Okay, so let us see how we draw the shape of the curve. And mind you, we also know the shape of the curve because the coefficient of s squared is positive. We are told that the shape of the curve is going to look like this, isn't it? And because it is repeating here, one of the turning points is going to happen here, and of course that will be the maximum because the maximum happens on the left. So it's going to be something like this. See, that is what it's going to be, and it will probably turn down here, and because there is the y-intercept, the curve will also be passing there. So that is how the shape of the curve is going to be. Let me try to draw it. Well, it seems my shape is horrible. Okay, so I'm gonna draw a nice shape now. I'm going to try draw a nice shape now, so something like that. And I think I should have this line coming down. No, this line is continually getting crooked. I don't know why, but it's because I didn't scale it well, so I'm having a big time trying to squeeze through that. Alright, then let me erase this a bit. Okay, so say something like that, and then the curve will turn pass over here. Yeah, so we are seeing that the curve is turning at one, that is at the repeated root here. Okay, so under normal circumstance we wouldn't have been able to know the exact value of the x coordinates, but here we do. So we can use this idea to form another equation. So let me try to make my point here. What I'm saying is that anytime that you're solving a cubic function question and you are told that the curve has two linear roots which are repeating, then you know that at that repeated root the curve is turning. So we have one turning point here, okay, and that is the minimum, but we don't know its x value for sure. But at the maximum it is turning exactly at the repeated root. So that is what is happening, and that is what I'm gonna do here. Alright, so with calculus there is one thing that is pretty much important. Okay, so we say at the turning point, dy dx equals 0. Alright, and because we have f of x, let me use f prime of x. It's the same as the dy dx. Okay, so at the turning point, f prime of x equals 0. So I'm trying to use calculus to solve this. And where is the turning point occurring? Now we have one turning point here. So here f prime of x equals 0. But do we know the value of x here? Of course not. We cannot be exact here. Another turning point is happening exactly on the repeated roots. So here too we can say f prime of x equals 0. But do we know the value of x here? Of course we do. That is -2. So this is the idea here. Because the cubic function has repeated roots, we can know exactly where the turning point, one of the turning points, is occurring, and we can use that to form an equation. And we can add that to the first equation, then we find a and b. So let's see. Alright, so the function f of x equals s cubed plus a squared plus bx plus 3. Okay, and we're going to differentiate this. So we have f prime of x. You grab the power for this term, you pull it down to multiply the coefficient of s cubed here. We have 1 here, so 1 times 3. Subtract 1 from the 3, we have x to the power 2. You grab the power here 2 to multiply a, we have 2a. Subtract 1 from here, we have x raised to the power 1. The power here is 1, 1 times b. Subtracts 1 from there, you have x raised to the power 0. If you differentiate a constant 3, you get 0. So we are now left with this function f prime of x equals 3x squared plus 2a, x to the power 1 is x, any number to the power 0 is 1. So we have this. Alright, so but we know that at the turning point, that is at tp, f prime of x equals 0. But we know that at the turning point, one of the turning points is happening where x equals -2, and at x where x equals -2, because we know that at the repeated root we have one of the turning points occurring there. So when we put -2 into the f prime, that is what we're gonna get. We should get the 0. Okay, and this means f prime of -2. Let me write this somewhere here. Let me write this here. So that means that f prime of -2 is going to be, let's put it into this function here. So we have 3 -2 squared plus 2a -2 plus b. But f prime of -2 is 0, so the whole of this is 0. -2 to the power 2 is 4. 4 times 3 is 12. 2 times -2, we have -4a. Then we have plus b. Alright, so let me write this well. I'll send the 4a and b to the other side of the equal sign. So I'm trying to send this to that end, so that will be 4a. And I'll send this also there. That will be -b, and we have 12 on the right side. So this is equation 2. So now I've been able to obtain 2 equations, and I can solve for a and b simultaneously. So let me write the first equation that we had right down here. The first one that we had was this. So that is 4a minus 2b equals 5, and this was our first equation. So we can solve this simultaneously. That is pretty simple. What we can do is that we can subtract the 2 or the 1 from the 2, or any. We can subtract equation 2 from 1 or 1 from 2. So I'm going to say equation 2 minus equation 1. So when I subtract 4a from 4a, I get 0. But when I subtract negative 2b from b, so I have this minus b minus negative 2b. And I have 12 minus 5, so that's 7. This will be positive here. So I'm going to have negative b plus 2b equals 7. And minus b plus 2b is b. So b is 7. Wow. So we had b to be 7. And of course, from here, I can find the value of a. So what do you think is the value of a here? All right, let me put b equals 7 in all the equations. So equation 2. Okay, let me take one. That one is pretty simple. 4a minus 2b equals 5. I want to find a, but b is 7. So 4a minus 2 times 7 equals 5. And I can go on here. I have 4a, and I have negative 2, 7, 14 here. Then I have 5 there. Okay. So let me do some small cleaning here. And I'll have 4a to be equal to 5. I'll send the negative 14 to the right side of the equal sign, and that will be positive 14 here. So I'm going to have 4a to be equal to 19. And when I want to find a, I divide both sides by 4. So I'm going to have this. So the value of a is going to be 19 out of 4. And I'm sure that's what we had in our first example, or in our first method, the method that we use here. That's what we had. We had the same thing here. So therefore we can say f of x, which is equal to s cubed plus as squared plus bx plus 3 to be equal to s cubed plus a. You know, we had a to be 19 out of 4, then b to be 7, 3. So that is the function f of x. And the next thing, we are told to find the zeros of the function. Now, as I said, in this scenario, we don't know the factors, so you have to divide and find them. And because we are told that x plus 2 raised to the power 2 is a factor, we are told that x plus 2 raised to the power 2 is a factor, and that is s squared plus 4x plus 4. So this quadratic is a factor of the function f of x. So I can use the quadratic s squared plus 4x plus 4 to divide the function s cubed plus 19 out of 4 x squared plus 7x plus 3 to get a linear factor here. When the linear factor multiplies the quadratic, I get a cubic function. So s squared divides s cubed, I get x times s squared, I get s cubed, x times 4x, 4x squared, x times 4, 4x. Let me subtract this from that, gives 0. 19 out of 4 s squared minus 4 s squared. What am I going to get? Let's do some simple algebra here. So I'm subtracting this, that is over 1. Find LCM. 4 here, 1 times 19, 1 here, 4 times 4, 16. Subtract 16 from 19, you have 3 out of 4. So that's going to be 3 out of 4 s squared. Subtract 4x from 7x, I get 3x. And then I have 3 minus 0 here, I'm going to get 3. Alright. The next thing here is s squared will now divide 3 out of 4 s squared, and that will give me 3 out of 4. So 3 out of 4 times s squared, I have 3 out of 4 s squared. 3 out of 4 times 4x, I'm going to have 3x. Yeah, 3 out of 4 times 4x, you know, the 4 will cancel, so you have 3x, okay? And 3 out of 4 times 4, you're going to have 3. So the terms here are the same. When I subtract this from that 0, this from that 0, 0. So that makes x plus 3 out of 4 also a factor of f of x. So we can say f of x can be written as the factors, that is x plus 2 all squared, and that of x plus 3 out of 4. And these factors will give you the zeros. The zeros are, you equate the linear factor to 0, and that will be negative 2 here. You know, this is repeating, so we have negative 2 and negative 2, and x plus 3 out of 4 to 0, then you get x equals negative 3 out of 4. So let's conclude by saying that, therefore, zeros of f of x are -2, -2, and -3 out of 4, because we have repeating factors here. So that is how this question can be solved. Thank you.